So I have a particle that's moving, so the position is given by this function s of t. So the first question says find the displacement during the first 5 hours. So displacement is how far did it go. So x1 or t1 is going to be 0 and x2 is 5 or t2 is 5. So at x equals to 0, if I substitute 0 into my equation, I'm going to get 100. When s equals to 5, I'm going to substitute 5 in for t, and I'm going to get 0. So my displacement is always the x2 minus x1. It's always the last minus the first. So it's going to be 0 minus 100, which is negative 100. And what that means is that the particle ended up 100 feet to the left of where it started from, or from 0. So 100 feet from the left. Part B says find the average velocity. And the average velocity is just your slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we already know what f of 5 is. F of 5 is 0. We already know what f of 0 is. That's 100. So we're just going to substitute those into our formula. And we get negative 20 feet per second. So that means that the average velocity was negative. So it was either going to the left or it was going down 20 feet per second. So notice that I also wrote the units. Part C wants us to find the instantaneous velocity. The instantaneous velocity is the definition, is the limit as h goes to 0. We're using x1 and x2. But we also found out that instantaneous velocity is also the derivative. So we're going to find the derivative. So the derivative is negative 32t plus 60. We want to find the derivative when x equals to 5. So we're going to substitute 5 into our formula. And we get negative 100 feet per second. So again, that means that my particle was going to the left or it was going down. D wants us to find the acceleration. The acceleration is second derivative of position. So we're going to take the second derivative. So notice that our acceleration is negative 32 feet per second squared. So that is gravity. So no matter what time, at what time, the particle is always going at an acceleration of negative 32 feet per second squared. Part E wants us to find at what time does the particle change direction. So what we're going to do is we're going to set the velocity equals to 0. Because when the velocity equals to 0, that means that the particle stops. And when the particle stops, that is the only time that it can change directions. So we're going to set the derivative equal to 0, solve for t, and we get 15/8 seconds. So at 15/8 seconds, the velocity or the particle changes direction.